This is part 3 of the preliminaries lecture series. The word transformation occupies an important part in every person's life. In mathematics, the idea of a function captures the idea of a transformation. Function. Now, recall that in high school, you were taught that the area of a circle, A, is given by the formula pi r squared. In other words, the area actually depends on the radius of the circle. Okay? Now, one way to view this area formula is to view it as a function of r. So we shall view A as a function of r, in the sense that what this function does, f, is it transforms, it operates on r, and it transforms it into a new number called pi r squared, which actually gives you the area. Okay, so one can you see this word function, it actually comes from the Latin word operation or transformation. So one way to view this is as some kind of machine where you feed in the radius of the circle and it transforms that number, the radius of the circle, into a new number, pi r squared, which actually gives you the area of the circle. Okay? And then the domain of your function f is actually the set of all the possible, which we shall write as df. This will be the set of all the possible input values. So because we're dealing with radiuses, this can only include positive numbers and the number 0. And then the range of f will be given, which we shall write as rf. This will give you the set of all the numbers that are spat out by the machine. In other words, all the possible areas of the circles. And in this case, this one again is positive, all the positive numbers. Okay. So, what we can view is that now, what we can view here is that one can also have what is called as, we can view this, we can view the input as what is called as a pre-image, and or something that, or a pre-operation, something that r was what was r, that was something before it got operated upon. So that is why we call it a pre-image or pre-operation stuff. Okay, so this is called a pre-image, and this output or the area is going to, we can also call it as the image, you see. And what we can do here is that we're now going to introduce the idea of a mapping diagram, which also it supplements the very useful idea of a graph. But what a mapping diagram does is it emphasizes this transformation from the pre-image to the image. So for example, for example, let's say I take my radius to be 2, then the area of the circle with radius 2 is going to be pi r squared, which is going to be nothing but 4 pi. So what we have here is that we have f, which maps 2 into 4 pi. In other words, f transforms 2 into 4 pi. Okay, so these are just the technical languages you must learn. And then in general, f will then map the pre-image r to the area pi r squared. Okay, so now what a mapping diagram does is that a mapping diagram is very similar to a graph. So what it does is that it's except that you actually draw your x and your y axis parallel to each other, okay? And in this case, what we can do here is that we can actually see a mapping diagram, unlike a graph, it emphasizes the actual transformations. So here, the radius of 2 gets transformed into this larger number, 4 pi. And then in general, the radius r is then mapped into this area pi r, 4 pi r squared, okay? So what we're going to do here is that let's illustrate mapping diagrams with what I shall call arithmetic functions, okay? I'll explain to you what are arithmetic functions, right? Okay, so the first type of arithmetic function that you learn is or these are, so because you see, so this is why this is actually called a line-to-line function, you see, because it takes real numbers on the real number line to another image real number on the image real line, okay? So let's deal with arithmetic functions, okay? So the first type of arithmetic function that you're going to deal with is what's called the constant function, okay? So this is the constant function. So in this case, let's give you a concrete example, k5 of x, and what it does is it always gives you 5. Or something that is more familiar is f of x is equal to 5, okay? So if I draw the mapping diagram of the constant function, okay, so it's just like the graph of a constant function, okay? So in the sense that I take my x and my y axis, but I draw them parallel to each other, both of them starting, you know, side by side. So this way I can see before and after more clearly. So notice that in this case, the number -1, 1, every number, you see, a constant function indiscriminately maps everything into the single number 5. So you see, -1, 1, 2, 7, all of them are then mapped into 5. So this is how the mapping diagram looks, and in general, x that gets mapped into 5. So this is how a mapping diagram is for the constant function. Now, if you were to draw the graph of the constant function, it's just the horizontal line that cuts the y-axis at 5, okay? So this is the graph k5 of x, okay? Right. Now, the second one is what is called the identity function. Now, in an identity function, what you have here is that the identity function I just is a lazy function. You feed it x and it does nothing. It just spits out x. So monkey see, monkey do, okay? It just repeats everything. So in this particular case, what happens here is that the graph of this function is obviously, as you know from high school, is just simply this straight line that cuts at 45 degrees. And then this is the function y is equal f of x equals x. Let's look at how the mapping diagram of this identity function looks like, okay? So here I draw my x and my y axis parallel to each other, okay? Starting them at the same points, so I can see before and after more clearly. And notice that 0, the identity function does nothing. So 0 gets mapped into 0, 1 gets mapped into 1. So there's no transformation. 2 maps into 2, and x gets transformed into itself. See, there's no transformation. So this is how the mapping diagram of the identity function looks like, okay? Then the third type of function is what is called a translation function, TC of x. And what this thing does is that whatever you feed it, it will just add on c onto it, where c is some known constant. So for example, if I choose t pi of x, it just adds pi onto x, okay? Then the fourth type of function is called a The fourth function is known as the magnification function. So in this case, the magnification constant function, what it does is that whatever it feeds, it just magnifies it up by a constant c. Yeah. So it's what you see, whatever you feed it, it will just magnify it up to a constant by a constant c. The fifth type of arithmetic function is what is called a linear function. This is your specialty. So in this case, remember, linear function is going to be ax plus b. So it's so many x's plus a number b. So in this case, you know straight away the graph of this is nothing but is any straight line. So in this case, the gradient a is actually positive. So this is the f of x is equal to ax plus b, where b is the y-intercept. Okay, that's the graph of it. And then the sixth type of arithmetic function is what is called the additive inverse function. Additive inverse function. This is additive inverse function, n of x. And this is just, it simply negates everything, okay? So in this particular case, so it's just nothing but the function f of x is equals negative x. And you all know how the graph of this looks like. It's just 45 slanting in the left side, okay? So this is y equals what? Negative x, okay? So this is called the additive inverse function. Right, and then finally, the last one is what is called the absolute value function or operation, and this is what we saw in a theme in our last week. So in this case, the absolute value of an absolute value function actually just is the absolute value of x. Okay. So this is so here this is what is called the absolute value function, right?